This is our first video on oscillations and waves, and we will be learning in AP Physics 1 mechanical waves, sound waves. We will barely touch light waves, but they're different type of mechanical waves. So mechanical waves can be longitudinal or transverse. They can be also orbital, like in the ocean, underneath the ocean. We don't touch those waves. We don't have to worry about that one in AP Physics 1. Or electromagnetic waves that we will cover in AP Physics 2 mostly. So there are certain characteristics in waves that you need to know. I'm gonna use the red marker on the graph right here where I have a wave. So right here on the top, this part is called crest and the bottom is called trough. The dotted line in between, this is equilibrium. So if the water was not moving or the wave was not moving, it would be in equilibrium. But the part that it gets disturbed by is the amplitude. So this is the part that how far it goes from the equilibrium up or down. Then the point, if you took the ruler and the point, I'm going to change the color to maybe green. The point from the crest to the crest is called the wavelength. So this part is called the wavelength, measured in meters, and it has a letter lambda. So it looks something like this. You draw this and this way. So it is lambda. And the amplitude has the letter A. Not sure if you can see it, maybe this color. So the amplitude has the letter A, so that's how far it is away from the equilibrium. And the time it takes to go from crest to crest is called period. So on the screen at the bottom left side, I have period. That's time from the crest to the crest, from the trough to the trough, or in other words, to make full wavelength. So that is the period measured in seconds. The frequency is the reciprocal of the period, and it has a formula. So the period is equal to 1 over the frequency, and the frequency is equal to 1 over the period. So the frequency is measured in hertz, and the frequency is how many times per second. So if you see your friends 5 times a week, so the frequency at which you see your friends is 5 hertz, because 5 times a week. But actually hertz is how many per second. So frequency is how many times happens a second. Amplitude is how far it's displaced from the equilibrium, measured in meters. Wavelength is the distance from crest to crest, from trough to trough, or one full wavelength. So the wavelength can be, let's say, from the point the wave is going up to the point the wave is going up. So right here, the red part, this is the full wavelength. Or I can say maybe the full wavelength is going to be not this part. Let me choose different color, maybe the green one. I'm going to say it's from here to the same position where it goes up right here. So from this point to this point is the wavelength. But it's always easier to say from crest to crest, or from trough to trough, or from the point when it's going down, so the wave is going down, to the point where it's again going down, or maybe it's from the point when it's going up to the next point where it's going up. So that would be the wavelength, and you see right here letter lambda. So that is the wavelength. And the speed of the wave. The speed is still measured in meters per second. So the speed is distance over time, but we don't have the distance, we have lambda, so that is meters, and over the period, the time it takes to travel. And here you see again the formula, the period is equal to 1 over the frequency, or the frequency is equal to 1 over the period. Also, the cause of all waves, the source of all waves is going to be vibration. Mechanical waves is the vibration. And I want you to remember that the wave itself is not traveling. So if you see right here, the water waves are floating, does not mean the water is traveling. So what happens is the molecules in the water have some kinetic energy and they push each other. So if this particle vibrates, it vibrates the next one, and then the next one vibrates the next one, and so on. So what is transferred is energy. So the particles in the wave do not move themselves. The matter does not move itself. What travels is the wave. And another interesting thing that I want to look at is the two different types of the waves, transverse and longitudinal, that we're going to be talking about. So in mechanical waves, we're going to be looking at transverse and longitudinal waves. So here's a good example of transverse and longitudinal waves. In the transverse, the matter is traveling, the matter stays in place. So let's say you have a rope here and you shake it up and down. If you imagine a dot or matter or another dot or another dot or another dot in the matter, even though the wave is traveling this way when you shake it, so the direction of the wave is that way, but the point itself in the matter is going to be moving up and down. So this one is called transverse wave, and I like that the matter is moving perpendicular to the motion of the wave. The wave is going to be traveling forward, but the matter propagates up and down. And then in the so the energy is going to be transferred forward when the wave is moving. The same here. If I have a spring and I compress and expand it, then I will have, let's imagine a dot and a dot and a dot. So every single dot in, or every single particle in the matter will be moving parallel to the motion of the wave. So in this case, if I have three different dots or the matter in the wave, the dot is going to be moving left and right as the wave is traveling to the right. So the wave will have the compression and expansions. So it's the same as having the wave looking like this. And so what we have to remember is that in the longitudinal wave, the motion of the particles in the wave is parallel or alongside, longitudinal alongside of the motion of the wave. And in the transverse wave, the motion of the particles perpendicular to the motion of the wave. And the matter does not move itself. It's just the vibration of the particle. It's not that the matter moved itself. And another concept that I have seen in the AP questions sometimes or study guides is the wave number. So the wave number is how many waves do you see in the unit of measure. So if this was 1 meter, maybe there are 20 wavelengths. So the wave number in this case would be 20 because there are 20 wavelengths within one unit or within 1 meter. Let's look at some questions and maybe understand how to use the formulas that I mentioned earlier. So here I have a wave traveling in a positive x direction as pictured. Find the amplitude, wavelength, speed, and period of the wave if it has a frequency of 8 Hertz. So the frequency is given. So I'm going to write that the frequency is 8 Hertz. And in the figure, the delta x is 40 centimeters. So delta x is 40 centimeters in this picture. And I know that actually from the crest to the crest is the wavelength. So that is actually my wavelength. So that is 0.4 meters. So the wavelength is 0.4 meters. The frequency is given. And y is 15 centimeters. And I know that the displacement from the equilibrium is called amplitude. So the amplitude is your y in this case. And that is 0.15 meters. Also, I learned just a few seconds ago that the velocity is equal to the lambda over the time. But 1 over the time is the frequency, so I could rewrite my formula as lambda times frequency. And because I have lambda, and because I have wavelength, and I have frequency, So the speed of the wave is equal to 8 times 40 centimeters, which is 0.4 meters. So your speed is equal to, or the speed of the wave is equal to 3.2 meters per second. They also asked me to find the period, and the period is equal to 1 over the frequency, which is 1 over 8, which is 0.125 seconds. Here's one more question. A wave has a wavelength, so I'm going to write the wavelength is 3 meters, and has a frequency. Find the frequency of the wave if it is a sound wave. So the sound wave, if they don't mention the speed of the sound for the wave, it's 340, but here they give you the speed of the sound is 343 meters per second. And so this is for the sound, and you can have the speed of the light, so I will say L, and that one usually is not mentioned. So all you have to remember, if you ever hear speed of sound, you need to take 340 if nothing is given, and the speed of light you have to know, which is 310 to the 8 meters per second. And I need to find the frequency. So the velocity is equal to lambda times the frequency, or lambda over the period. So the formulas that I need to know, that frequency is 1 over the period, or the reciprocals of each other. And here I can find the frequency for the first one. I have the velocity, which is 343, divided by 3, the wavelength, and I get the frequency of 114.3 hertz. And if I used different velocity for the frequency of for the same velocity and the same wavelength, but for the light, the frequency would be equal to 310 to the 8 divided by 3, the wavelength. So that gives me 10 to the 8 hertz. So 10 to the 8 hertz would be the frequency of that electromagnetic wave, because the light wave is part of the electromagnetic spectrum. We're going to be talking about it in the future videos. Here's the next example I want to look with you at, and find the wavelength of an electromagnetic wave with a frequency that is 9 gigahertz. And 9 stands, the giga stands for 10 to the 9th. So, which is actually the microwave. So if they say find the wavelength and they give you frequency, I know that the speed of light in the previous video, sometimes they use the letter C. Do you remember the formula mc squared, the famous Einstein's formula, mc squared? So C stands for the speed of light, and that is 310 to the 8 meters per second. So if I know the velocity is equal to the wavelength times the frequency, or the wavelength divided by the period, I can use this formula to find the wavelength. So the wavelength is equal to the speed of light, which is 310 to the 8, divided by the frequency that they give you, which is 910 to the 9th. So if I cancel 3 and 3, and I can cancel 10 to the 9 and 10 to the 9, or 10 to the 8 and 10 to the 8, what's left is 1 over 30, which is 0.03333 meters. So the wavelength of this wave would be 333 or 33.3 millimeters. You could write 333.3 milli 10 to the negative 3 meters. In the next part, they say find the speed of the sound wave in an unknown fluid medium, because the sound will have different speed in different medium. The speed of the light in the vacuum is 310 to the 8th meters per second. But the speed of the light is slowing down when it hits the medium. This is why we'll often see refraction of the light when, let's say you put the spoon inside of the glass and you don't see. So if you have a glass with water and you put the spoon, you will see, or a pencil, you're going to see something like this. And that's because of refraction. That's because the light slows down in the water. Another interesting fact about the waves is that the waves depend on its frequency. So if you have a rope and you shake the rope, then it will depend on your hand how many wavelengths you create per second. So the frequency will depend on the source, on your hand. It doesn't depend on anything else. So the frequency always stays the same. So electromagnetic light, like radio waves, microwaves, visible light, infrared, ultraviolet, gamma, so all of those have specific frequency. And because they will have the same velocity, and they're all transverse waves. So the longitudinal waves would be the sound waves, because when I speak, then I create the air pushing each other in the longitudinal way along the way the sound is produced. But the electromagnetic radiation, which is visible light, is part of the electromagnetic radiation that travels at the speed of light. Those are transverse waves. So I just wanted to tell you that, so you would remember that the frequency of the wave will only depend on the source that produces the wave, or on the mechanical vibration that produces the wave. But the velocity and wavelength will change in different medium. So in this case, they tell you that this sound wave is an unknown fluid medium, so it has different velocity. It doesn't have the velocity of the sound 340, which is in the air. And also the sound wave, or mechanical waves, they need a medium to travel. A medium means the stuff, so air, water, metal. And the sound waves will travel faster when the molecules are closer to each other, because they can pass the energy from one to another. Because they are longitudinal, so the molecules in this case, they push the next one, they push the next one, they push the next one. And so the energy travels faster when there is more of the medium closer to each other. So let's say in metal, the sound is going to travel faster than in the air. Back to our question. Find the speed of the sound wave in the unknown fluid medium of frequency. So they will give you frequency, the frequency is given, and they give you the wavelength, and I need to find the velocity. So the velocity in this medium is going to be the wavelength times the frequency. And now if I multiply these guys, which is 567 times 2.5, I will get 142 10 to the third meters per second as the velocity. Here's one more example that I want to look with you at, and we're gonna take the vertical increments as 1, so each increment is 1 meter. So here they ask you, find the amplitude, and I'm just going to do one question for you here. Find the amplitude. So the amplitude is 1, 2, 3, 4, 5. So I'm going to say the amplitude is 5 meters because I chose each one of them to be one increment. Find the period. And this is the time, so it is in seconds. So the period is from crest to crest, from trough to trough. So I'm going to take from crest, from crest to crest. So here is my period, or I can take it from the point where it starts to go up from the equilibrium to back to where it starts to go up from the equilibrium, so from this point to that point. So I see that the period is 8 seconds. 8 seconds. The frequency is 1 over the period, so that is how I find the frequency. So the frequency is 0.125 because I have to divide by 8, and frequency is measured in hertz. So I found these 3 things so far. And that is all that they ask you to find. So I'm just going to do one example because they're pretty simple. I want to solve other questions in this video as well, and you can practice them on your own online in our video lessons. I'm gonna do just a few from each problem as well. So here they ask you what's the frequency based on the period that is given. So let's say the period is given 1/60 seconds and the frequency is 1/1/60 seconds. So the frequency is going to be the reciprocal, which is 60 hertz. And in the next question, I'm gonna take maybe this number and I'm gonna say, okay, the frequency is 0.01 hertz, then the period is 1 over the frequency, which is 1 over 0.1. I times the top and the bottom by 10, or numerator denominator by 10, and I get 10 seconds. So that will be the period for this question. Let's look at some very simple questions as well, so we just understand how to use the formulas and apply the information that is given. A skipper on the boat notice wave crests passing his anchor chain every 5 seconds. So there is a wave passing every 5 seconds. So the period is 5 seconds because you see one full wavelength passing every 5 seconds. He estimates the distance between the wave crests to be 15 meters. So between the crest and the crest, which is the wavelength, so this is your wavelength, so that means the wavelength is 15 meters. And he also estimates the speed of the wave, and the speed of the wave is equal to the wavelength over the period, or the wavelength times the frequency. So he estimates the velocity is equal to 15 meters divided by 5 seconds, and that gives you 3 meters per second. A weight suspended from a spring is seen to bob up and down. So here is the equilibrium, and you have the weight, and here is the spring, up and down 20 centimeters twice each second. So up and down, so from here to here there is 20 centimeters. What is the frequency, period, and amplitude? So the amplitude, I can say, is gonna be 10 centimeters because it jumps down and up by 10 from the equilibrium. And then they say twice each second. So it goes up and down twice each second. So anything number per second is frequency. So from here I can say that the frequency is 2 hertz because it's twice in 1 second. And the period is 1 over the frequency, which is 0.5 seconds. And that is all that they ask you to find in this question. And I think this question is pretty easy. They give you electromagnetic waves. So this is the part of the visible light is electromagnetic wave, travels at the speed of light, which is 310 to the 8. They give you the frequency and they ask you to find the wavelength. So the wavelength is going to be the velocity, 310 to the 8, divided by the frequency that they give you. 100 mega means 10 to the 6. So that gives you 3 meters per second. Here's another question. Mosquito flaps its wings. So 680 vibrations per second. So how many per second is the frequency right away? So that is 680 vibrations per second, which produces the annoying buzz. How far does the sound travel between wing beats? In other words, calculate the wavelength of the mosquito sound. The sound travels at 340 meters per second, so the velocity is given 340 meters per second. And they want you to estimate the wavelength. The wavelength is going to be the velocity over the frequency from the formula. And you have velocity is 0.5 meters. So here's one more question. The sound wave has a frequency of 180 hertz and wavelength measured 2 meters. So you have the frequency, you have the wavelength, find the speed. So the speed is the frequency times the wavelength, so that gives you 360 meters per second. And then how long will it take for the wave to travel the wavelength of a football field, which is 90 meters. So you have the distance equals to the average velocity times the time, and they ask you how long, so they ask you for the time. The distance of the football field is 90, so that's distance, divided by the velocity, which we found 360. And so I divide by 3 and by 3, top and bottom, and I get 12, which is 1/4 and I should have said right away 1/4, 0.25 seconds. So it will take 0.25 seconds to get across. And then what is the period of the wave? So the period is 1 over the frequency, and the frequency is 180. So that will give me 5.5 milli 10 to the negative 3 seconds. So here's one more question. A rifle fired in a valley with parallel vertical walls. So there is a wall and there is a wall, and the rifle is fired somewhere here. The echo from one wall is heard 2 seconds later, so it means there and back takes 2 seconds. So it takes 1 second there, 1 second back. The echo from the other wall 2 seconds after the first echo. So if for the first echo it took 2 seconds to get there and back, then for this one it's going to be 4 seconds. So the total distance, the total time there and back is 4 seconds. That means it's 2 seconds there and then 2 seconds back. So the valley, they ask you how wide the valley is across. So the distance is equal to average velocity times the time. And they don't give you the velocity of the sound, so because they don't give that velocity, I always take 340 times 3 seconds, because one way is 3 seconds and the other way is 3 seconds. So that gives me the distance across for the valley is, 1020 meters wide. So this will conclude for our video. I'm gonna stop here because I have to fit my videos within 30 minutes. So this was introduction to waves, and continue following the videos. In the description you will see the link to the next video to our lesson, and thank you for watching this one, and I will see you in the next one.